So, hello everyone. My name is Mr.Bellic and we are watching Bellic Robotics. So, in today's video, we are going to do image analysis and transformation. We have already done two things which consider in transformation and analysis in our previous video, like histogram and k-means and perspective transformation. In this video, we are going to do other four transformation analysis technique like color filtering, image comparison, watershed segmentation, and background subtraction. And we will also go through is like what is transformation and what is analysis, and we will go through these codes. So without wasting much time, let's get this part started. First of all, we will go through the topic like image analysis and transformation. So, what is image analysis and what is image transformation? Like, image analysis is a process of extracting meaningful information from image, like detecting the object which is in image or measuring the similarity. Like here, in this image, there is the object which is a dog. So, it's our analysis of the image, that what we find out in the image. And while in transformation, it refers to modifying an image to make it easier to analyze, like changing color, removing background, and other things. Okay, just like this is A, and we just tilt it like A, so that we could make it easier for the analysis which we are doing. So transformation help us in analyzing things. Okay, so this was all about image analysis and transformation. Now we'll go through what is image comparison, color filtering, watershed segmentation, background subtraction one by one. Image comparison. So, if I say that I have to compare two things, on what merit two things can be compared? One is difference and one is similarity. Exactly. So, in similarity, we use SSIM or structural similarity index. So SSIM is just a similarity index, like it compared to image, and then tell that how much contrast or structure is same in the image. It's like how similar two images are. It ranges from -1 to 1, and it's like 1 means perfect similarity, and -1 means it's like not at all similar. And second parameter is difference. For difference, we will use MSE, mean square error. We have used this in our school initial schooling. Like what is MSE? And in like MSE give the average square difference between two things. So it's like it give that how much two images are different. Like it give the error like how much image is different. If we take two images, same image, then it will give MSE equal to 0 because there is no error or no difference in the image. So higher MSE means higher difference, and like similarity, one similarity means it is perfect similar, -1 means there is no similarity in the image. So that's all about the similarity, difference, and image comparison. Now let's see how we can do this using the code. So let's jump to the code. Okay, so you have to give me a subscribe for this effort, as I have recorded this video already. Now I'm recording it again because I missed the code part where my coding screen was working. So it was just I was explaining it and my PPT was working at the background. Okay, so first of all, we will import some libraries, which is of course CV2. Wait a minute. Yeah, CV2 for OpenCV, NumPy for numerical things, Matplotlib for plotting, structure similarity from scikit-image.matrix. This is our similarity, okay, of similarity function which we are importing. Then our favorite IMSO function which we use in every video. Then MSE. This is normal basic maths MSE function which we have studied in 10th or 12th standard. Now this function we will make compare. First of all, we will show both the images. Then we will check that if the both image size are equal. As if the image size are not equal, then it will not the MSE and SS will not work. As like MSE and SS is the similarity or the error, but if the sizes are different, then how can you calculate the error? So it we will check that both sizes are equal or not. If not, then it will make both sizes equal, like height and width will be same. Then it will be converted to BGR to gray, like grayscale, as we want grayscale. Then we will do MSE and SS and then print it. Okay, so this is our compare function. For images, we will take two images, frog1 and lava, and this image we will create by increasing the brightness in 200. Okay, so we will compare these three. First, frog and frog, same image. So MSE is 0.0 and 1.0 is SS, which is max. After that, we will compare frog and lava. You can see that MSE is 2851 and similarity is 0.13. Like not much similarity because they are not similar. And now here, similarity is 0.63, which is great because they're same image, just in 2000 brightness. But the MSE is very much because there is the all the pixel are increased very bright. Okay, so this was all about the image comparison, and let's move to the next topic. So color filtering. Okay, this don't have much theory. Okay, so what is in color filtering? In color filtering, we take an image and then we take a color. Like I say that, like I have a image of this oil and I want green color. So in color filtering, we will select green color and then remove every other color of image except then green color. So how we can do it? Let's see in the code. Okay, so code of the filtering part. First, CV2, NumPy, and Matplot, and our favorite function of plotting. Now, we will take a image of a Indian truck. I love this type of truck as I am Indian and Punjabi. Like I have Punjabi powers. Okay, so here we can see it's like we have blue in the background. Okay, and we are taking the blue as a upper and lower end. This is the HSV range of lower and upper range HSV range of blue color. Okay, so first of all we'll convert this image in HSV and then we will add the mask of HSV lower and upper. Okay, lower is the range where the blue is started and upper is the range where blue ended. So this is the mask. Here where is the blue is there is the all pixel are white and other color they are 0. So 0 is of other color and white is 255. So when we now we will use bitwise AND. So we will AND of this and this, then it will give only the blue color. So this is the final color. Like my favorite truck just vanished and only blue color is required. So this is all about the coding of the filtering of the color. Let's jump on the next part. Okay. So what is segmentation? Okay, segmentation means to divide some parts of a whole complete thing. And in watershed segmentation, what we do, like we make the 0 pixel as a valleys and the pixel with the highest brightness, means 255, as the peaks. Then we start pouring the water and fill up all the valleys. So that makes some gap between two segments. Here, with these watershed valleys, we found that there are three segments: one segment, second segment, and third segment. So this is how watershed segmentation took place. To know what is watershed more in more detail, let's jump on the coding. But this is because of OpenCV perspective only. But if you are here for only segmentation part, then you can skip this code, because for segmentation we have new technology like YOLO segmentation and other things which can perform more easily and more oh yeah, which we can use to make our code more efficient and more easily. So let's jump on the code. Okay. Clear output. First of all, we will import the libraries as we do always. Then we will write our favorite function, I'm so function, where we just have to give the image and it will plot the image of that desirable size for us. Then we will run it. Then we will give a image, and here we are just converting into the grayscale as we don't need a colored image. After that, we are using otsu function for threshold. Like we will make our image technical black and white. Okay, and otsu do algorithm make it automatic. So we are using otsu. And here was the original image with the coins, and this is our binary image. So otsu is pretty much accurate. Now we will remove some noise. We will take kernel, make a kernel by 3 by 3 and make a opening. Here we will use morphology X, like morph open, where first we will dilute, then expand. Okay, so here we will use this opening and kernel for making sure bg. Sure bg is the background which we know that it is a sure background. Okay, now we'll make a distance transformation using distance transform. Here we will give the parameter like opening and cv2 dot dist l2. It will help us to let us know that which foreground is like 100% sure, and we will give it to the cv2 dot threshold function, which is of course favorite function, and let's just run it. Okay, so after doing this, we know that these are the sure foreground. Foreground means the region of interest. So this is our region of interest, which we know this is for sure, and this is our sure background that we know for sure, and this is unknown. We don't know that this is the foreground or this is the region of interest. So for that, we will use a connected component part, which we will say the marker. This will connect all the binary image, the things which are not connected yet, and after that we will convert all the markers to the 1 from 0, so that all the background will be 1. Now all the region which is unknown will become 0. Now we will give everything to the cv2.watershed, the algorithm which we will use, and this will give the segments. So you can see that how this is giving the segments, like this one coin and this is another coin, this is third coin, but you can see that here when the coin are too much connected, it's giving the wrong segment, like there. And the code is also much complicated. We have used many things, so that's why we don't use watershed algorithm now. But as for the course and OpenCV perspective, it was important. So this was all about watershed algorithm, and we will not go in much depth because it's useless now as we use YOLO. So background subtraction. Okay, we will not touch this topic as in background subtraction. What we do is just it's like a video where our dog is running in the video and background is constantly changing. So we just remove the background of it and we only extract the dog which is running. Generally we use OpenCV to track the dog, but now as the technology changes, so we don't do it from that way. So we generally use YOLO or other object detection models which extract the dog, and we can easily have the motion detection or other things which we do from background subtraction. So as far as the perspective of OpenCV, this was the last video and our playlist end right now. And but the perspective of the computer vision, we will have other videos on the YOLO and other DeepSeek or other things which we will continue explore and add the videos which is the latest technology which will add on your skills and other things. So until then, I think we just say bye bye. I hope you like this video. Thank you. Bye bye.